Welcome students. Now we will be covering the differentiability. In the last lecture we have covered limit as well as continuity. Okay, so after covering the differentiability we will be going to cover the limit for the indeterminate forms. So let's first discuss what is differentiability. So in the differentiability, let fx be any real function, okay, and let's say a be any real number on which we are checking the differentiability. Okay, so under the differentiability, as like in the limit we used to calculate the left hand limit as well as right hand limit. In the same scenario, in this differentiability we will be calculating the right hand derivative as well as left hand derivative. So how do we calculate the right hand derivative? So right hand derivative is calculated as limit h tends to 0, and we are checking differentiability at a. So f of a plus h minus f of a divided by h. Okay, and if it exists, then it is said to be as right hand derivative, and it is represented like this. Okay, now talking about the left hand derivative. So left hand derivative goes like this: limit h tends to 0, and we will be going in the left direction of the value a. So a minus h minus f of a, and here instead of h this would be minus h, and if this is existing then we will represent it as l f dash of a, and this is called as right hand of derivative. So what's the condition for derivative differentiability? Condition for differentiability, what's the basic condition? So if a function is said to be differentiable, function is said to be differentiable at x is equals to a if and only if when right hand derivative is equal to left hand derivative. So this condition must be satisfied. Okay, and this is the basic condition for differentiability. So let's focus on some of the numericals to get more clarity over the topic. Okay, so let's first discuss our first question. So question is like this: show that the given function fx is equals to 1 plus x, and this is 5 minus x for the condition if x less than equal to 2, and if x greater than 2 is not differentiable. So we have to prove that the function is not differentiable at x is equal to 2. Okay, so again, what's the procedure? We just calculate the left hand derivative and right hand derivative. So let's first focus on calculating the right hand derivative. So we have to check the differentiability at 2. So right hand derivative is given as limit h tends to 0, and this is f of, instead of formula, if you look at the formula, f of a plus h, so a will be equal to 2, so 2 plus h, and in this case 2 minus h, and we will be needing the value of f of 2 here. Okay, so first let's check what's f of 2. So here you will see, for the condition x less than or equal to 2, the function is defined as 1 plus x. So let's first calculate f of 2. So can we say 1 plus 2, and this is given as 3. Okay, so here what's the condition? F of 2 plus h minus f of 2 given by h. Okay, so here again if you look at the condition, the value is greater than 2, so this function would be applicable. So instead at the place of x we'll replace the value as 2 plus h, and function of 2 we already know, that is 3, and divided by h. So can we say 5 minus 2 minus 2h minus 3. So can we say this is getting cancelled, and at the denominator can we say h is cancelled? The answer is sorry, it's not minus 2, it's minus minus h. So if we calculate the answer, then this is minus 1. Okay, similarly let's calculate the left hand derivative as well. So left hand derivative will be limit h tends to 0 f of 2 minus h minus f of 2, and at the place of h it would be minus h. So again, now this function is less than 2. So for less than 2, the upper function is applicable. So can we say 1 plus x? So at the place of x we will be replacing it by 2 minus h. So 1 plus 2 minus h, and function of 2 is already we have calculated above, that is 3, and this is minus h. So let's say 3 minus h, minus 3 divided by minus h. If we say 3 and minus 3 are getting cancelled, the answer is 1. So here you can see the right hand derivative and left hand derivative are not equal. So this is the condition that it is not differentiable. So we have checked the differentiability at 2, so we'll say that the function is not differentiable at x is equal to 2. Okay, now let's focus on one more numerical. Again, a question is there. Show that the function fx is equals to mod of x minus 2 is continuous. So we remember we have to show here continuous but not differentiable at x is equal to 2. Okay, so again if you look at the condition, we'll revise the last class as well, the continuity property and the differentiability property as well. So what's the continuous property? For the continuous, the left hand limit and the right hand limit as well as the function value should be equal, and for the differentiability we have to check right hand derivative as well as left hand derivative, that is represented by r f dash a, and this is represented by l f dash a. Okay, so checking out the first, what would the things be needing in this is f of 2. So we are checking the differentiability at x is equal to 2. So first calculate f of 2. So f of 2 is calculated as mod of 2 minus 2, and this is equal to 0. So one thing is calculated. Now we are first checking the conditions for continuous. Okay, we are first checking the condition for continuous. Okay, so again now we have to calculate the right hand limit. So how do we calculate the right hand limit? We have to check it for the x is equal to 2. So limit x tends to 2 plus f of x. So how do we write the things? As limit h tends to 0 and the function is 2 plus h. Instead of h we will be writing it as 2 plus h minus 2. Here you can see. Okay, so what's the function? Like limit h tends to 0, 2 will be getting cancelled, and mod of h is already h. So limit h tends to 0 h, and it is answer is 0. Okay, now let's calculate the left hand derivative. So limit x tends to 2 minus f of x. How do we calculate this? Limit h tends to 0, and this is now 2 minus h minus 2. Again 2 and 2 will be getting cancelled. So limit h tends to 0, can we say mod will make the things positive, and limit h tends to 0, again h, and again it's 0. So you can see the three conditions are being satisfied, that is left hand limit is equal to 0, right hand limit is also equal to 0, and the function of value at 2 is also 0. Okay, there you can say f of a is equals to 0 or f of 2 is equals to 0, and all are 0. So hence given function is continuous at x is equal to 2. So first case is satisfied. Okay, now let's focus for the differentiability. So how do we check the differentiability? So in order to calculate the differentiability, first we'll check the right hand derivative. So how do we check the right hand derivative? Limit h tends to 0, f of, we are taking right hand side of 2, and f of 2 divided by h. So f of 2 plus h. So limit h tends to 0, let's write the function as mod of x minus 2. So can we say 2 plus h minus 2 minus what is the function of 2, that is already we have calculated here. So this is 0 and this is 0. Can we say this will be getting cancelled? So limit h tends to 0, can we say mod of h by h, and mod of h is already so h, so it will be 1. Let's calculate the left hand derivative at 2. So limit h tends to 0, f of 2 minus h minus f of 2 divided by h. So limit here it will be minus h. So limit h tends to 0 and 2 minus h. So instead here 2 minus h minus 2 minus 0 divided by minus h. So 2 will be getting cancelled. Limit h tends to 0, mod of minus h divided by minus h, and now the numerator will become the positive. So numerator will positive, denominator is negative. Here you will see the answer is minus 1. So you can see the right hand derivative at 2 is not equal to left hand derivative, hence it is not differentiable at x is equal to 2. Clear? Now let's go to the topic limit. So before studying the topic limit, we will be okay, let me write down some of the points which might be necessary for you. Like every differentiable function is continuous, but converse is need not true. Okay. Second condition is that differentiability implies continuity. Okay, if a function is differentiable, then it is continuous also, but continuity does not implies that it is differentiability. Means if a function is differentiable in nature, then definitely it will be continuous in nature, and if it's not continuous, then it's definitely not differentiable. Okay. And the third point is that any polynomial function is continuous and differentiable everywhere. Okay, so this is all about the limit, continuity and differentiability. Okay, so in the next lecture we will be covering about the limit for the indeterminate forms.